क्लास चालू करते हैं। Good morning, all. Shall we start the class? Yeah, I will share the screen with you. So, yesterday So have you solved this problem? Have you solved this problem which we Yes, Saurabh. So have you got the value? The value which you were saying? I do not know because I don't have the solution for this problem right now. So I I don't know the solution. Okay. So we discussed this problem. After that, we were discussing the cone clutch, and I have given you the equation for the cone clutch. Then also told you that the cone clutch is not used the in practice. Okay, so these are the equation. Now today we are going to discuss the centrifugal clutch. Okay, so let me see if I have got the presentation on the centrifugal clutch. So if it is there, then we can discuss this centrifugal clutch. So centrifugal clutch, yes, it is very much given here, but there are no, you can say, the practical or calculation thing. So this is another type of clutch which is used in vehicle, usually in two-wheeler. This clutch used to be there in the previous old vehicle Luna. Now Luna is discontinued. So what it consists of? So it consists of a number of shoes on the inside of the drum or rim of the pulley. The upper surface, basically, when let us see the figure first. Okay, so these are basically the friction lining. These are called as the shoes, and as this particular shaft rotates, this friction surface will be getting in contact with the driven shaft, the hub of the driven shaft from inside, and the driven shaft and the driving shaft, they rotate at the same speed. The major problem here is to find out what is the engagement speed at which these shoes they will contact with this particular surface. So that we are going to see. So this is basically the cone clutch, which is, or centrifugal clutch, which works on the principle of the centrifugal force. So the upper surface of the shoe are covered with the friction material. The spider is fitted on the driving shaft. So this particular part is known as the spider. The complete thing is known as the spider. The spider is fitted on the driving shaft. When centrifugal force is equal to spring force, the shoe is just floating. But when centrifugal force higher than the spring force, then the shoes move outward and come in contact with the driven member and press against it. The increase of speed causes the shoes to sorry, press harder, and clutch transmits more power. So this is how the engagement takes place. So we are now going to do the analysis of the centrifugal clutch. Then we will see the loss of the advantages and disadvantages of this centrifugal clutch. So I'll shift to the blackboard. Blackboard पे shift हो जाएंगे. I will shift to the new. Sorry. So centrifugal clutch. So if I have to draw the figure of the centrifugal clutch, it will be, this is the outer drum, this is the center portion. Now this, you can say, the friction surface. There is a spring over here. Okay, and the spider is there. This is the arrangement which will hold this complete assembly in place. So this is nothing but the centrifugal clutch. You can say that this is the inner surface of the drum. This is spider, then this is the friction surface, and this is spring. The complete assembly is basically the shoe. Now we need to determine the determination of the weight of the shoe. So that is, this is basically the complete assembly which you can say as the shoe. I will show you the exaggerated view of this particular shaft. First is determination of weight of the shoe, because this is the design parameter as far as the centrifugal clutch is concerned. So let M is the mass of one shoe, mass of one shoe. Then N is the number of shoes. R is the distance of CG of shoe from center of the spider. So it is the distance of CG of shoe from this particular point, from spider center. So if I have to draw the exaggerated view of the shoe, then I will draw it like this. Let us say that this is the reference line and this is vertical. Then shoe is something like this. This is the exaggerated view of this outer portion. फ्रिक्शन मटेरियल वाला जो है ना, जिसके ऊपर फ्रिक्शन मटेरियल लगा हुआ है, इंक्लूडिंग फ्रिक्शन मटेरियल. So that is basically the shoe. This, if you join this, then this angle is nothing but angle theta. And let us say that this is G, that is the CG of the shoe. This is located at a distance of small r. Okay, so this PS is nothing but the spring force, and this is PC, which will be acting through CG, is the centrifugal force. This is the shoe area. Then this side, let us say if you draw this, then there will be some thickness which you can term as B, and the outer radius is of the shoe is capital R. So force which will act here due to friction is F, and this is the width of the shoe. ये जो end portion, sorry, ये जो है ये length of the shoe is this, the length of the shoe. So these are the total dimensions which are to be there for the shoes. So we are saying that capital R is the inside radius of the inside radius of rim. That means this distance, this is the inside radius. Basically, this is the inside radius. We assume that there is very negligible clearance between the shoe and the inside radius of the rim. Now omega is the angular running speed of the rim or pulley. So omega is the angular speed of rim. This is the outer rim. Actually, so this should be, sorry, this should be inside rim. ठीक है, आउटर का तो ये फिर एंगेजमेंट होने के बाद रहेगा. So omega 1 is equal to angular speed at which the engagement begins. Say the drive will be given to the inner shaft. That means this particular portion, the drive will be given. Then based on that, the shoes will be moving in the outward direction because of the centrifugal force, and there will be contact of the shoes with the outer portion. So if you see this figure, the next figure, so this is the outer portion and this is the driving shaft. कि जब भी ये ड्राइविंग शाफ्ट का ओमेगा ऐसे होगा कि at that particular speed it will get engaged with the outer, you can say, hub, or you can say what is outer, क्या बोलते हैं इसको, yes, so outer rim को ये touch करेगा. So this is the speed. Now we have to do the analysis of this. So first is the frictional force acting tangentially on each shoe. So what is that? So we'll write down the expression. So frictional force acting tangentially on each shoe, on each shoe. We are doing the analysis for that. This is equals to F is equals to mu in bracket the centrifugal force minus spring force, because spring force will be opposite to the centrifugal force. So jitna normal reaction hai, the, you can say, the resultant normal reaction multiplied by mu, that is going to be the frictional force which will act tangentially on each shoe. Now this is basically the net radial force. If you say that this is the net radial force. Okay. Now PC, that is the centrifugal force. PC is centrifugal force. So this is given as at each shoe, at each shoe, this is given as m r omega square. Okay, and the PS is the spring force. PS is inward force on each shoe due to spring. So this is usually, I will write down the expression and then will explain you. So this is 9 by 16 m omega square r. Here the assumption for this is the engagement angular velocity omega 1 is equal to T by 4 of omega. So actually it is the spring force should be mr omega 1 square. So if you put the value of omega 1 square as 3 by 4, so you will get 9 by 16, because this is, yes sir, isn't spring going to bend as it is rotating and it comes with the contact of a stationary drum? Sir, why it will rotate, sir? The spring is so stiff that it is going to have the force, but not to the extent of it complete expansion. So it will not bend. Prajwal, it is not going to bend. You attach the string. If you are pulling the spring with a certain force, then how it can bend, sir? You have got the spider to give the strength or to guide the spring in this particular, you can say, space. So there is no issue of bending of the spring. Does that answer your question, sir? सर यहाँ बेंडिंग नहीं होगा सर, स्प्रिंग का साइज भी छोटा है. ये सर हमने एग्जैगरेटेड ये दिया है. स्प्रिंग का बेंडिंग कब होगा? इफ द लेंथ ऑफ द स्प्रिंग इज मोर and the stiffness of the spring is less. If it is the soft spring, then in that case you can expect that there can be bending. But if you see this the springs which are used in this particular clutch, those springs, they are little bit stiffer. Okay, so unless you get the proper centrifugal force, they won't expand. So that is why the engagement speed is taken as 3 by 4 of omega. सो 75% जब ये स्पीड को जाएगा रोटेटिंग स्पीड के शाफ्ट को, तो वो रोटेट होगा. दैट मींस दिस विल बी डिजाइन्ड बेस्ड ऑन दिस ओमेगा हैज टू बी डिजाइन्ड in such a way that the minimum speed or the shaft clutch should be designed in such a way that at this particular omega, that means the lower RPM of this particular you can say case, the should be equal to your engagement speed. Then and then only the moment you accelerate the vehicle, the centrifugal force will still increase more. Okay, so now the frictional torque acting on each shoe. So we will write down. Up till now, is it clear? Omega is the maximum angular velocity. No sir, it will not be the angular velocity. See, angular velocity will keep on changing because this is the omega which you are getting from the engine shaft. So please understand this. I will show you this sketch once again. So the omega is the speed of the driving shaft. It is not maximum. That's what I am telling you. That means it is not that you will get the engagement only during the maximum speed. Otherwise the vehicle you will have to accelerate the vehicle till the engine reaches the rated RPM. No, it is not like that. It is basically designed in such a way that if you it should engage at the idle RPM. Once it engage, then you go on increasing the speed of the engine. These shoes, they will firmly hold here, and the centrifugal force it is going to increase. If the centrifugal force is going to increase, the frictional force acting on tangentially on each shoe will increase, and that is how the torque is getting transmitted to the driven shaft. Clear, sir? Yeah. So the frictional force, you can say that the frictional force, if we want to calculate, then the frictional torque, frictional force we have already calculated. So frictional torque T acting on each shoe, this is given as F into R. This is equals to mu PC minus PS spring force into R, that is equals to mu PC का वैल्यू कितना आया है mr ओमेगा स्क्वायर माइनस 9/16 mr omega square whole thing multiplied by capital R. Now the total frictional torque to be transmitted. So total frictional torque to be transmitted is equals to N into F into R. Okay. Now this is the first thing. Then second is basically the size of the shoe. So we can find out the size of the shoe. Size of shoe, how to find out? So let L is equals to the contact length of the shoe. So L is equal to contact length of shoe. B is width of shoe, which I have shown. This is the width. So B is width of the shoe. And R is the contact radius. Then theta is the angle of shoe. So theta is angle of shoe. Okay, subtended by shoe at the center, then we can say that this is the intensity of pressure P of shoe exerted on the shoe, or you can say that L into B into P, where P is the intensity of pressure. Intensity of pressure that has to be equal to the resultant force PC minus PS. Okay. Now usually this P is generally taken as P is taken as 10 Newton per centimeter square. As I told you that in automobile we have to assume certain values. So here they assume that P is equals to 10 Newton per centimeter square and theta is equals to L by R. Generally theta is taken as pi by 3. So generally, because there are certain thumb rules, so from here you can say that pi by 3 is equals to L by R. From here you can say L is equal to pi by 3 of R. तो अगर ये L आपने pi by 3 of R यहाँ रख दिया तो you can get the value of B. Okay, so from here just I'll shift to the next page और from put this L यहीं पे लिख देता हूँ, आपको कुछ कंफ्यूजन नहीं चाहिए. आपने अगर यहाँ रख दिया L तो आपको B मिल जाएगा, width मिल जाएगी. So this is how you can design the centrifugal clutch. तो यहाँ से आपको फ्रिक्शनल टॉर्क कितना है वो मिल जाएगा, कितना ट्रांसमिट करना है. तो वहां से आप मास निकाल सकते हो शू का और यहाँ से लेंथ एंड विड्थ निकाल सकते हो. सो दिस इज हाउ यू कैन डिजाइन द सेंट्रीफ्यूगल क्लच. नाउ सेंट्रीफ्यूगल क्लच के कुछ फीचर्स है which we should know. Sir, anybody is having any issue as far as this discussion is concerned और सेंट्रीफ्यूगल क्लच? सर कोई डाउट है तो पूछिएगा। सर यहाँ से जो मैंने ये टोटल फ्रिक्शनल टॉर्क जो है वहां से आप वेट मास निकाल सकते हो सर शू का, ये फॉर्मूला है, इसमें आपको आर मालूम रहेगा तो आप मास निकाल सकते हो सर। ओके, सीजी कितना चाहिए। एंड ये जो है ये सर जनरल चीजें है जो अपने को थंब रूल से आएगी। सर आगे बढ़े। ओके, तो सर next is there are certain features of this centrifugal clutch. Let us try to understand. So centrifugal clutch, सबसे पहले सेंट्रीफ्यूगल क्लच की एक इंपॉर्टेंट चीज है, इट डज नॉट रिक्वायर clutch pedal for operating the clutch, for operating the clutch. This is the only clutch which will be always in disengaged condition. If you want to engage, then you will have to start the vehicle. Okay, तो ये सर शुरू में डिसएंगेज रहेगा। अगर आपने व्हीकल शुरू किया, द मोमेंट इट गेट्स दी यू कैन से RPM, then it will come into the action. Okay, second, the vehicle can be stopped in any gear without stalling the engine. Sir, this is the another feature of this centrifugal clutch. That means you can stop the vehicle in any gear. The moment you stop the vehicle, the RPM will get reduced and automatically the clutch will become disengaged. So it doesn't matter in which gear the vehicle you are moving the vehicle. Okay. The third feature, vehicle can be started in any gear by pressing accelerator pedal. So please understand that this is the liberty which you can get with the centrifugal clutch. That means you can start the vehicle in any gear you want. Okay, so usually if you might have heard that the Yamaha RX100 was the vehicle, that was the only vehicle which I know can be started in any gear. Otherwise, all other bikes you have to first bring the vehicle to the neutral gear and then basically start. So probably they might be using, I am not sure, probably they might be using the centrifugal clutch or the connection between the engine and the transmission system. So that was the vehicle RX100. Nowadays it has been discontinued because its engine cannot meet the current emission norms. But that was the vehicle which people used to start in any gear, and there will not be any issue with that. Now let us come to the advantages and disadvantages of the centrifugal clutch. It says that the advantages is simple and inexpensive and need little maintenance. Okay, little maintenance means you just have to keep the watch that is there any uneven wear on the friction material. If there is uneven wear, then at that particular portion you will find that there is no contact of the shoe and the power transmission will have some problem. So there will be some slippage because of that. It is automatic and any kind of control mechanism is not necessary. Help to prevent engine from stalling, this I have told you just now. Engagement speed can be precisely controlled by selecting the spring. So this is the good point, that the engagement speed you can control it by precisely by selecting the spring, by selecting the proper speed. So whether it has to engage at 75% of the shaft speed or more or less. Disadvantage, loss of power due to friction and slipping. This I have explained you, that if there is chances of getting uneven wear, then there will be loss of power. Not suitable for high torque transmission due to slip at heavy loads. So it says that it is very much possible that the moment this particular shoe is pressed under very high centrifugal force, then there is the chances of the slipping of the there may be chances of slip between the shoe outer surface and the rim inner surface. Shoes engage at full power or near full power and get heated very quickly, may cause overheating. So this is another issue. He is saying that if you maintain the engagement speed which is related to your rated speed, then in that case the overheating may cause. And one more important thing, that if you are racing the engine that much, because to reach to the rated RPM you have to raise the engine RPM, that means you have to burn more amount of fuel. So that is not advisable, because in that particular case you are polluting the environment. So all these vehicle components, they are very sensitive. The design is very sensitive. If it has to be the vehicle has to meet the emission standards. Okay, so please understand that these are the probable disadvantages of the centrifugal clutch. Now electromagnetic clutch, we will not discuss it right now. We will be solving one problem based on the design of the centrifugal clutch. Now in this particular problem, I will require your help for, you can say, calculation, because I don't have the solution for this. Means I have not solved it myself. So let us see what best we can do as a team, because if we don't do it as a team, then uh, 15.2 kilowatt change it to 1.472. चलो ये करके देखते हैं सर, इसमें भी कुछ गड़बड़ है ये प्रॉब्लम में। चलो लेकिन सॉल्व करके तो देखते, कैलकुलेशन तो ठीक से करके देखते हैं। राइट डाउन अ सेंट्रीफ्यूगल क्लच, a centrifugal clutch is to be designed to transmit to transmit 1.472 kilowatt power at 900 RPM. The shoes are 4 in number. The shoes are 4 in number. The speed at which engagement begins, the speed at which engagement begins is 3/4 of running speed. Full stop. The inside radius of pulley rim, the inside radius of pulley rim is 15 centimeters, 15 centimeter. The coefficient of friction, the coefficient of friction may be taken as 0.25. Determine first weight of the shoe, weight of the shoe, size of shoes, size of shoes given CG of shoe is 3 centimeters below the rim, below the rim. तो सर ये सॉल्व करके देखते हैं. मेरे पास इसका एग्जैक्ट सॉल्यूशन नहीं है. आई एम जस्ट टेलिंग यू. So I will be totally relying on whatever values you tell me. Okay. तो सर सबसे पहले तो इसने एंगुलर स्पीड दी है वो निकाल लेते हैं रेडियन पर सेकंड में. सो ओमेगा इज इक्वल टू 2 पाई n बाय 60. तो ये हो गया आपका 2 इंटू पाई इंटू 900 बाय 60. सर ये कितना आता है बताइए. बाय दैट टाइम आप कैलकुलेट करके बताइए. ओमेगा इज इक्वल टू 3/4 ऑफ ओमेगा 1 इज इक्वल टू 3/4 ऑफ ओमेगा 94.24. सो 94.24 रेडियन पर सेकेंड. सर ये ओमेगा कितना आएगा 0.75 इंटू 94.24. ये कितना आता है सर ऑलमोस्ट 70.65 रेडियंस पर सेकंड. ये आ गया. नाउ सर अभी टॉर्क निकालते हैं. यानी ये ओमेगा 1 जो है यहाँ एंगेजमेंट बिगिन होगा जब ये ओमेगा यानी इंजन क्रैंकशाफ्ट जब 94 आरपीएस से घूमेगा एट दैट टाइम 70 आरपीएस से ही ये एंगेज करना चालू कर देगा. ठीक है. सो टॉर्क इज इक्वल्स टू 2 पाई अच्छा पावर इज इक्वल्स टू 2 पाई nt by 60. So from here torque is equals to P into 60 divided by 2 pi n. तो सर टॉर्क निकालिए कि कितना आएगा सर. पावर दिया है 1.472 इंटू 10⁻³ इंटू 60 डिवाइडेड बाय 2 इंटू पाई इंटू. अभी ये जो पावर रहेगा इसके लिए हम लोग आरपीएम अगर 9000 लिए, हाँ 9000 आरपीएम पे ट्रांसमिट करना है. तो सर टॉर्क बताइए कितना आएगा. सर कृपा करके टॉर्क की वैल्यू बताइए. मेरे पास वैल्यू नहीं है, नहीं तो मैं आगे नहीं बढ़ पाऊंगा. वन 15.612. so 15.618 न्यूटन मीटर. तो सर अभी फॉर्मूला लिखते सर. ये टॉर्क T इज इक्वल्स टू म्यू PC माइनस PS ब्रैकेट कंप्लीट इंटू रेडियस R इंटू नंबर ऑफ शूज N. तो सर इसका कितना आएगा सर. ये 15.16 म्यू दिया है 0.25 तो चलो सर पी सी माइनस पी एस निकाल लेते, फिर हम लोग ये करेंगे। आर कितना दिया है? आउटर रेडियस इज 15 सेंटीमीटर, द इनसाइड रेडियस ऑफ द पुलेरी में 15, तो 0.15 और 4 शूज दिए हैं। तो सर इसका पी सी माइनस पी एस कितना आता है बताइएगा। So we know that PC minus PS is equals to MR omega square minus, sorry, minus 9 by 16 MR ओमेगा स्क्वायर। तो सर ये MR ओमेगा स्क्वायर बाहर निकाल लेते, मल्टीप्लाइड बाय 7/16 आएगा, तो ये आएगा 101.066। चलो ठीक है, ये आएगा 101 पॉइंट, सर अच्छा 104 नहीं है ना सर? 104 है कि 101 है? क्या ले सर, ओमेगा का वैल्यू ये है, चलो 104 लेते, चलो 104, ये आएगा 104.12, ठीक है 104.12। अभी सर हमको मास निकालने का है, रेडियस कितना दिया हुआ है, तो हाउ मच इज द रेडियस? CG 3 सेंटीमीटर उसने बोला है बिलो द रिम, यानी 12 आ गया। ये m इंटू 0.12, ये ओमेगा कितना दिया हुआ है, ये 94.24 इंटू 7/16, सही बात है सर। सो फ्रॉम हियर गेट द वैल्यू ऑफ m निकाल के देखो सर शू का कितना आता है। 0.223, so 0.223 kg, सो यानी ये m आ गया आपका 223 grams, so this is the mass of each shoe, okay, so 223 ग्राम almost is the mass of each shoe। नाउ यानी ये 1 पाव के करीब करीब है। देन साइज ऑफ शू, साइज ऑफ टू, तो सर साइज ऑफ शू कैसे निकालेंगे, ये L इज इक्वल टू π/3 इंटू आर, तो सर ये 3.14 डिवाइडेड बाय 3, आर का वैल्यू अपने को कितना दिया हुआ है 15 सेंटीमीटर, तो 15 ही रखते, तो सर ये कितना आएगा 5 पाई, यानी लेंथ कितना हो गया सर, अब बताइएगा 15.7 के करीब करीब, 15.707 सेंटीमीटर। नाउ यू नो दैट L इंटू बी इंटू पी, ठीक है, LBP, so LBP is equals to PC by PS, that is equals to 17/16 M R ओमेगा स्क्वायर। अपने को L मालूम है, अभी P का वैल्यू कितना लेना सर, P का वैल्यू लेते हैं, P का वैल्यू उसने कितना दिया हुआ था सर प्रीवियस इसमें डिजाइन, कितना लेते हैं P का वैल्यू के लिए, एक मिनट, P का वैल्यू इज जनरली 10 न्यूटन पर सेंटीमीटर स्क्वायर, तो इसको सर करके देखते हैं। सो 10 न्यूटन पर सेंटीमीटर स्क्वायर, दिस इज assume, तो दिस विल कम आउट टू बी 10⁵ न्यूटन पर मीटर स्क्वायर, एम आई करेक्ट सर, यानी करीब करीब 1 बार। सो यहाँ लेंथ आपको हमने कितना निकाला है, लेंथ ऑफ द शू, ये आ गया सर आपका 15.707 इंटू 10⁻⁻², ये मीटर में हो गया, बी हमें निकालना है इंटू 10⁵ और ये 7/16 ये mr² जो हमने निकाला है वो है आपका 104.12। तो सर यहाँ से अभी b निकाल के देखिए कि कितना आएगा सर। b का वैल्यू 6.628। ओके, सो 6.628 मिलीमीटर, दैट इज दी मिलीमीटर या सेंटीमीटर में आएगा सर। 0.6 सेंटीमीटर आएगा, बहुत ही कम आ रहा है अथर्व, जरा चेक करके देखिएगा सर। सर ये वैल्यू चेक करके देखिएगा कि कितना आता तो। ओके ठीक है, सौरभ का भी वही है। सो 6.62 यानी काफी कम आया। तो ये प्रॉब्लम के डेटा में कुछ तो भी गड़बड़ है। दैट वाज माय डाउट। ओके, सो डोंट वरी about it. So this is how we can design or we can solve the problem based on the centrifugal clutch. Now if anybody is having any doubt here, please do ask. We'll try to solve one more problem on the cone clutch, and after that we will discuss the electromagnetic clutch ki kya hota hai to, and then that will close the chapter based on the clutch. So anybody is having any questions, please do ask. सर आज दोपहर को हमारा टेस्ट है। पीएस फॉर्मूला इज नॉट क्लियर सर। पीएस इज स्प्रिंग वाला फॉर्मूला सर। हाँ, स्प्रिंग वाला फॉर्मूला। एक मिनट सर, मैं आपको जस्ट बता देता हूँ, एक सेकंड, मुझे फिर से चालू करना पड़ेगा। हाँ, ये जो सर ये पीएस वाला फॉर्मूला है आपका, ये जो नहीं क्लियर हुआ, ये सर देखिए, ये स्प्रिंग में कितना फोर्स डेवलप हो सकता है, द मैक्सिमम फोर्स यानी जितना एंगेजमेंट के लिए लगेगा उससे ज्यादा तो स्प्रिंग में फोर्स नहीं डेवलप होगा। ओके, तो एंगेजमेंट कम होगा सर। ये जब उसका ये जो आरपीएम है ये 3/4 ऑफ ओमेगा है। मान लो ये आरपीएम है 1200, तो 1200 का 3/4 यानी 900 से ये मूव होते चलेगा तो यहाँ ये टच करेगा, देन टोटल 1200 rpm will be getting transmitted to the outer wheel. So this is basically the engagement speed. So maximum force, how much a spring can develop? It can develop 3/4 ओमेगा स्क्वायर, बिकॉज उसके बाद वो यहाँ पे चिपक जाएगा। तो आपने कितनी भी स्पीड बढ़ाई, so this will become the one body, and that is why we are saying that the force which will be getting developed into spring is going to be 3/4 times of m r omega 1 square, where omega 1 square is the velocity at which the shoe will touch to this particular rim. So it will, the spring force will become mr omega 1 के जगह आप 3/4 रख दो। So 3 का स्क्वायर हो गया 9, 4 का स्क्वायर हो गया 16, so 9/16 mr omega square. Now it is clear सौरभ? ओके, चलो ठीक है। सो सर आज दोपहर को अपनी टेस्ट है, so all are requested to appear for the test. ओके, तो सर आपको कैलकुलेटर हो सकता है आपको लगे, तो कैलकुलेटर भी आपके पास रहना चाहिए। ओके, व्हाट विल बी द टॉपिक? टॉपिक जो रहेगा पहले क्लास से आज तक के हमने जितना डिस्कस किया वो सब सर उसमें रहेगा। ठीक है, तो कोई चिंता मत करो, आसान सी टेस्ट है, कॉपी करने का प्रयास मत करो, क्योंकि कॉपी करने से सर आपको रैंडम क्वेश्चन है तो आपको प्रॉब्लम हो जाएगी। तो आपकी इच्छा, बाकी जो भी आपको करना है। ठीक है, तो मैं सर आपको ग्रुप पे अप्रोप्रिएट इंस्ट्रक्शन दे दूंगा, प्रैक्टिकल में आपको इंस्ट्रक्शन बता दूंगा। कुछ भी इंस्ट्रक्शन नहीं है, मैं टोटल क्वेश्चन देख लेता हूं कि कितने हैं। तो सो टोटल क्वेश्चन, ईच क्वेश्चन विल कैरी 4 मार्क्स, द नेगेटिव मार्क इज -1। if you miss the question, then there will be 0 weightage for that. If you give wrong answer, it will be -1. If you give correct answer, you will get 4 marks. Okay, so this is how the test is going to progress. I will tell you the time depending upon the number of questions. Let me see, I will tell you in the practical class. Is that clear, sir? Okay, sir. Now over from my side, you can leave the meeting if you do not have any question.